Okay. So the first thing we want to do is EF print EF. And like, as you can see, if you go through, if you write, okay, let's see, let's open up new script all the time so that if you even make a mistake, you can go back and change. Yeah, it's not recommended to work on command window because you have to type everything again. So new script. Then if we do A equals 5, B equals 1, and if we say, oh, C equals then A minus B, and that means pretty much 5 minus 1, 4. And if you want to display this information, then you have to type EF print EF. I mean, there will be other commands as well, but for now, okay, it will display. Then we just do EF print EF. Then you just write inside parentheses, and it's a single quote. Everything you want to do is single quote. C is the difference of A and B, and that's what you want to do. But then your cursor, you want to start that cursor on the next line. So this is the backslash n, so new line. And we need to save, or if you run, it asks to save lab for example. Okay, then you will see the output here, C equals 4, which is expected. And then it prints what we wanted to print. Okay, so EF print EF. And this slash n means the cursor, if you look at here, when it prints C equals, C is the difference of A and B, and the cursor goes into the next line. If I do not write this, I mean, we still get the thing. Let me run this code. Yeah, and the cursor is here on the same line, and which is not, doesn't look good if you look at this output here. So the tradition, I mean, is the slash n, start new line. Okay, so let's try to display all the squares, A, 1, 4, 9, all the way to 11. Okay, so I'm gonna put this and comment. So the next thing is, let's see, one for loop. All right, CLC, so that this screen, the command window, whatever you see, will be just cleared, CLC. Then for I equals, let's say one small for loop, I through 11, I want to write A equals I squared. Okay, I squared, and I want to suppress this output. I don't want to show all 11. Then now if I want to display the very last, then I have two options. I can just do disp 11. If I do this, then run, it will give me the very last one. Or you just write A11. Okay, that would give the same answer. Pretty much, yeah, it's what it's get to go into this disp A11 or any other things. Okay, so that's another thing. Let me put comment on this. Now, when we do some type of sequence and you want to specify the 10th term of the sequence is something, and the sequence can change, but your code remains the same. So here is example 2 in your lab. We start with, let's say, S1, very first term is 1. Okay, S1 equals 1. Yeah, what I'm talking about, when we make a mistake, we can go back and change. If we are doing on editor, or here's new script file. Okay, S1 is 1. I don't want to display that, so suppress the output. For I equals 2 through 10, I want to write down, yes, the sequence as previous term I minus 1. Okay, that's a typo, so I can fix S minus 1 plus 3, then end. If I do this, then I'm going to see all I starting from 2 to 10. I have not suppressed the output. Let's run this. Yeah, it shows you everything. First, when I equals, so from here. So it gives 2, then all the everything. So we want to suppress the output. And if you want to just see the very last, you can just type yes 20. Not 20, there is no 20. What happens if I write 20? Let's try. Yeah, there is no 20 because we are going from 2 to 10. So that would be not true. So up to 10, then it will give us the number. Okay, and but I want to write down, let's say 10th term is 28. Let me clear this. CLC. So if I do this, I'm going to get 28. But I want to display that in terms in language. So then we write f print f inside parenthesis single quote. Now here's the case. Now we want to write in discrete D, that's the number, TS. So that percentage D can be changed into floating if you write dot F, I'll show you. And dot 2F means 2 floating digits, that means 2 decimals. So that the percentage D term of the sequence is again discrete, and start next line D. Okay, this is incomplete. This is the code. Now we have 2 places to fill in, the percentage D first and here. So we need to specify that. So we want to show 10th term because that's the very last one. Okay, so that is what? So I, that's the very last one. Then this I corresponds to first percentage D. And we want to display yes I that. So this will correspond to second. You might have more than 2 arguments. Sometimes, I mean, that will be the case later. Then you write down here. So if I run this, then it says the 10th term of the sequence is 28. Okay, I want to find 5th. Then I can just change to 2 to 5 here, or there can be other cases as well. And it show you the 5th term of the sequence is something. Okay, now let me clear this here. I want to go up to 10. If I change this percent discrete to, let's say, point, just a floating number. Okay, just F. Here to F. I don't have to change. I can put D here. Okay, if I do this, then that's the floating number. So 10th term, okay, this is kind of not good. 10.0000 term of the sequence is 28. Maybe if I do percentage D here floating, then the 10th term of the sequence is 28 point something. Or and if you are working on money problems, then 0.2 F, just the floating 2 digits. And this is just discrete, maybe, and you just run. The 10th term is of the sequence is 28. Okay. Now it is showing us only the very last, because here's the 10. Okay. What happens if I put this F print F inside the loop? Copy. I'm going to write down here before I end the loop. So let me delete this. Can someone guess? Did you guys try? What do you expect? Are you guys there with me?
Yeah.
Oh, okay.
I'm in.
Okay, if I run, then it will show you everything, all second, third, fourth, all the way to 10. And this is the bad choice for decimal, 2 decimal places. So D, if we do this, let me clear this, or I can always put CLC here, then the good news is then this thing will be cleared. So we get a nice output here. Then now you should be able to do the lab. So I'm gonna stop sharing.